Hello, welcome to another drive-by code session where my friend WaiKit writes some code and I explain what he did. This is going to be part 4 of a series on async await. For those of you out there who are really trying to learn async await, trying to wrap your head around it, I recommend this resource. There's a good async await tutorial on javascript.info for that. This episode is going to be dealing with Node.js, so we're going to be working within Node.js and see how async await applies in that environment. We will use the help of a couple of NPM modules. We'll introduce them as we go, and we'll be dealing with some Markdown. Markdown is, in short, a shorthand for HTML, so you can write text like this, and it'll generate the corresponding HTML for you. You might have been familiar with it if you ever written README files on GitHub, for example. So without further ado, let's get into it. So WaiKit starts off setting up this Node.js project by making a git ignore file, which prevents the Node modules folder from getting checked into source control. That's always a good thing to do. And then he uses the npm init command with a -y to generate a new package JSON file. So that's a convenient way for you to do that without having to type up this file yourself. It contains metadata about this Node.js project. Okay, so he's gonna write some code that does stuff with the file system. But first, we're gonna need a text file to read. So we have a hello.txt, and then we'll write this file system call, file system.read file, to read in this file. But I see a typo here, so if you run this, we get fs.read file is not a function. That's just because the f is supposed to be capitalized. So we fix that, and we run the command again, and we'll get this buffer object. So this buffer object is the parameter 2 of this callback function. There's also a parameter 1, which is the error object. We'll see that later. What are you supposed to do with this buffer object here? A buffer object represents a bunch of data. If we want to see the string that data represents, we can just do a toString on it. You can also alternatively just concatenate it with any string. We'll use the empty string, and that will work just as well. Now, what if the file didn't exist? We typoed the name of the file. Well, if that happened, we would not get a buffer object. So this error message is saying, I cannot read property toString of undefined, saying the thing to the left of this dot here, the buffer, is undefined. What gives? Well, the way that JavaScript, or Node.js, I should say, communicates that there is a problem is by giving you this error object. And if we print out this error object, we'll see this. There's some information in there. The error object also has a .message property. And if we printed that out, if we printed that out, it'll say, it'll print out the error message. In this case, it says no such file or directory. We're trying to open this hello.txt. If you have experience with Node.js, then it was probably preached to you that whenever you do an I/O operation like this, you should always check for the possible existence of an error object, and you should do something like this. Just ignore those console messages for now. So you should do something like this. So if there's an error, then you might want to handle it, maybe by printing out appropriate message to the user or doing something else. And then if there is no error, then you can do your normal course of action. Alternatively, you could also do something like, do an early return and then then you don't have to write this else statement here. And that you might prefer that code because that requires one less level of indentation for this line, where you would write code for the normal course of action. Okay, now we're gonna do something a little bit more complex. Okay, so all right, so we're gonna install the Markdown module from npm. The Markdown module is a module that will take Markdown code that looks like this or looks like this, and then if you tell it to Markdown or if you tell it to render, it's going to generate some HTML code for you. So the plan is we're going to make a file that has Markdown in there. We just changed the hello.txt to hello.markdown and wrote some Markdown code in here. So this is going to end up being an h1 tag in HTML, and the word inside the stars, that's end up going to become an M tag, and this guy is going to end up being a paragraph. Okay, so now we'll change this code to read from the MD file, and then if we were able to correctly read the file, then we'll use this Markdown module to convert the code from the buffer, which is the Markdown code. It's going to convert that using the render method, as we saw in the tutorial example, and give us some HTML code. And once we have the HTML code at hand, we're going to write that out to an HTML file. So let's do that. Okay. So now with the write file API call, we also have to handle errors, because the write file could also potentially fail due to various reasons. One might be the location you're trying to write the file to, it doesn't exist. So you also should, if you were a good citizen, handle errors coming from a write file operation. So let's see that. And we have a problem here because WaiKit forgot to put this generated HTML into the write file call. So he fixes that, and now that should work. So that generated the HTML file, hello.html, and it looks like this, based on this markup code here. So that's pretty cool, but you can see this code, the amount of nesting that this code has is already getting to be fairly a lot, and this code is starting to get unwieldy. And if we do something even more, so let's say we're gonna have a HTML template that this HTML is going to go into. So the template will have a doc type in the HTML and the body tags, etc. So let's go ahead and do that. And this is what he came up with. So we have an HTML template now, which has these sections in all caps, these words in all caps, which are meant to be replaced. And here is reading in the template file and then replacing those words, the title and the content, with the desired replacement. So now the HTML, to generate that HTML file, looks like this. There's a little bit of indentation problem, but that doesn't matter. We're not going to fix it. This code, as you can see now, is getting fairly hard to deal with. We're basically approaching callback hell. And async await is a solution to this problem. So let's see what if we wrote the same code, the exact same functionality using async await, what would this code look like? So let's do that. So first we're going to install the MZ library. So the MZ library, the tag name for it is modernizing Node.js, and it basically puts a wrapper around all of the standard libraries that Node.js has out of the box, such as the file system module, but it'll wrap it around, give you a wrapper around the file system module and give all of the APIs that the file system module has to you, but except give them to you as promise-ified APIs, so that whatever you use, whether it's read file or write file, read file or write file or fs.exists, all of those API calls will give you promises. And if you remember, a promise object is what we need to work with async await. So, okay. So now that we have MZ, we can use MZ/fs instead of the fs module. And then the first thing you do when you're doing async await is you make an async function, so you can write your await statements. Okay, so now if you write read file, fs.read file, that's going to give you a promise object. And because it's a promise object, you can await it now. So if you print out this code, you also get a buffer object. So what do you do with a buffer object? You do a toString on it, like so. So because this guy is a buffer object, you do a toString, now you get the markup code. And we're going to do a similar thing to get the template HTML. And then we're just going to steal the markup rendering code and the template replacement code, steal it from the other script and put it in here. And then finally we're gonna do a file system.write file and await on that. And this is basically the equivalent code to this piece of code. And as you can see, there's just a lot less code here. This is much more condensed and easy to read. There's less nesting to this code, so reading it from the top to bottom is very straightforward. Now, where did all of the code go? Well, a lot of it had to do with this error handling code. So why is it that in the async await version we don't need error handling? Well, error handling does need to come into the picture. So if we printed out this success message here, if there were an error in any of these statements, say there's a file, the file, it doesn't exist here in the first operation, then everything would error out, and the rest of the statements would get skipped. So the way you would handle this is by using a catch statement here on the return value of this main function, because little did you know that all async functions return a promise. So the return value of this main function when you call it is actually a promise. So, and as you know, with a promise, well, if you were familiar with promises, you would know that a promise has a catch method, which will allow you to handle an error coming from a promise. So you could do something like this. I could just chain it like this, and just one line here is sufficient to handle any of the errors coming from any of these statements, as opposed to having a separate error handling statement for each one. So that is the end of this code session. I want to stop it here. At least this video goes too long. WaiKit and I will team up again to bring you more async await content, as well as some other content as well. So I hope to see you in the future. Thank you for watching.